everyone. Today we are presenting our final report on the topic of security posture of the Secure Health Research Lab at the Geneva Institute of Precision Medicine. Uh, Here we have another two pens, Shakila Devendra and also Apu Kumar Patel. Here, our presentation covers the full life cycle of a security assessment from analyzing the real world breach to developing organizational policy and implementing technical hardening controls in the simulated network. That's our main target of this report. Okay, you can see our second slide, introduction and organizational context part. Here, the SHRL environmental base at the Geneva Institute of Precision Medicine. I previously mentioned that. And here, uh, the SHRL is a high value research environmental base uh, company. It has sensitive genomic sequences data. And if the data is no the because this data is very critical and highly regulated, but if any security failure could happen here, there is a that lead to intellectual property loss or ethical violations. So our report bridged the gap between the real high level security documentation and also actual network implementations. So that's the our main goal of this project. And next slide is we take analyzing the incident, phishing incident, and we take here the scenario like the senior researcher received a targeted spare phishing email from the fake international consortium. So there is a very huge breach. The malicious software download led to the installation of the remote access Trojan, we call it RAT. Mm, and also the attacker later movement. The later movement trying to jump our general research network to our most sensitive data servers. So that's the main threat of these phishing incidents. So I invite my friend Shakila to present our next slide, slide 4. Thank you very much.
Thank you, Rashmika, for explaining the introduction and the phishing incident scenario. I will now continue by discussing three key areas: identified red flags in the attack, the secure collaboration and software policy, and the high value assets and responsibilities within SHRL. These sections focus on how the attack could have been detected earlier and what controls are needed to prevent similar incidents in the future. In this incident, there were several clear warning signs of a phishing attack, although they were easy to miss in a research environment. First, the researcher was asked to download unapproved software. Legitimate academic collaborations usually use official platforms or internal IT approved tools, not direct executable downloads. Second, the software requested institutional login credentials. This is a major red flag, as trusted collaboration tools normally use single sign on systems, not manual credential entry. Third, the attacker used a fake website that closely resembled a trusted platform, even though it looked professional. It was not approved by SHRL. Finally, the email created a sense of urgency and authority, pressuring the researcher to act quickly. These psychological techniques are commonly used in phishing attacks. To prevent similar incidents, SHRL introduced a secure collaboration and software policy. This policy controls how new software and collaboration tools are introduced into the research environment. It applies to all researchers, staff, and technical personnel, ensuring consistent security practices. Only approved collaboration platforms are allowed. Any new tool must go through a formal security review by IT or cybersecurity team to check for malware risk and data protection issues. Most importantly, institutional credentials must never be entered into unverified third-party tools, as credential theft is often the starting point of larger security breaches. SHRL manages several high-value digital assets that require strong protection. These include DNA sequencing servers, AI systems, and high-performance computing clusters which store and process highly sensitive genomic data. Genomic data is a prime target for attackers because it cannot be changed once compromised. A breach could lead to legal issues, reputational damage, and loss of research trust. Responsibility for security is shared. Cybersecurity engineers monitor threats and respond to incidents. Research operations teams ensure system availability. All staff members must report suspicious activity. Regular security reviews are conducted annually or after incidents to keep controls effective. That brings me to the end of my section. In summary, recognizing phishing red flags, enforcing secure collaboration policies, and protecting high value assets are critical for maintaining security in sensitive research environments like SHRL. I will now hand over to the next presenter who will explain the risk management plan, incident response process, and technical implementations. Thank you.
Hello guys, so now we talk about the 7 slide incident response plan. The incident response plan outline how SHRR responds to security incident. Configuration checklist are used to verify system integrity during the after incident. Routes make have securely SSH access control listed login enable switch to enforce vigilance and port security. Employees must report incident using approval communication channels and depends severity. The next slide is about the network audit reveals several weaknesses. The native balance was left was VLAN and the unless ports remained active, increasing attack surface, password policies exiting but were not considered environment. And additionally, the DNA sequences is several leak static IP address and difficult gateway affecting reliability and security. This slide is about the technical implementation. To address these issues, several technical controls were implemented. Trunk configuration was updated to remove VLAN 1 as the native VLAN. Routers with the using encrypted enable secrets and protected VLANs and the access controls. This slide is about the conclusion and alignment. Like in conclusion, SHRL now benefits from a unified defense approach, technical controls such as VLAN segment and a port security directly Support document security policies. The network is more realizing against attack and the lateral movement. However, security is an ongoing processing required continuing awareness, monitoring, and periodical review. This slides is the academic and industrial reference is used to support our analytics and recommendation, including psychosecurity guidance network. Thank you so much for listening. We are happy to answer any question. Thank you so much.